Hello all. Now we discuss some concepts related to an image. As we are very much familiar that in our environment, a substance which is radiating will definitely release some kind of energy to its surroundings in the form of a light. Whenever these light rays will hit the target or an object, any object in its surrounding, as soon as it is done, the light will get immediately reflected by an object. And if suppose a camera is the one that is going to capture some object in the surrounding, this camera converts the light photon into the electrical signal where ultimately we get an analog image. So the analog image is converted here into a digital image by the spatial sampling. In fact, sampling is done along the x direction as well as along the y direction. And so here after it, quantization of intensity values is done so that we get finally a 2D array of numbers. Where you can see the same thing here. The sampling here, we are having here the analog image. So sampling the 2D space, because this is an analog image, of course it is a 2D space. So sampling the 2D space on this regular grid. After which, what we are doing here, quantization of each sample to its nearest value. We are just rounding it off. That is what generally happens. But ultimately, we are going to get here as a result of image. So, images are represented by a 2D function, that is as f of x comma y. So, we are having here x coordinate as well as the y coordinate. And f of x comma y is nothing but if x comma y is some location in this image, okay, so that means I am going to call this x comma y locations as spatial coordinates. At particular location, I am going to get a value at that particular location, which infers me that it is the brightness or the intensity level or the intensity value at that particular location of a pixel in the image. So this f of xy, that means this brightness at particular point in an image is characterized here by two components. One is the illumination and the second one is the reflectance. Then how these intensity values are related with the illumination and reflectancy means, as we know from the fundamental concepts of physics, that is, whenever an object that is radiating something, let it be a light rays, these light rays will be striking the surface in the form of a flux. So definitely the object will be the object. So the object may be a point, or it may be a flat surface, or it may be some zigzag surface also. Whenever an area is receiving some flux from the radiating surface, immediately the surface tends to reflect something to its surroundings. Okay, so at this point, I would like to capture this point through my camera or through my eye. As soon as I would like to capture this object, so as this object is radiating something into the environment, okay, that means it is acting as a radiating object. It is showing its radiance properties, because as previously the surface of this object has been illuminated by some light source through its flux. Now this object is going to radiate something. That means it is acting as a newly radiating subject here, which is captured by a human eye or a camera. So the output product ultimately a camera produces here is nothing but an digital image. Okay, that means the image is nothing but it is expressed in the function of illumination as well as the reflectance. Okay, anyhow, the light is a form of energy. That means f of x comma y must not be a 0. This is what it generally happens for a digital images. And you can see the same concept here. I have taken some satellite image some portion of the satellite image is being highlighted in this manner here. So I have got the sampled and quantized version here, where the complete black box, that means here each and every box is nothing but a pixel. So here this pixel is completely some nearer to black, that means logic 0. We know according to the digital systems, logic 1 is nothing but it is completely white, and logic 0 is nothing but it is completely black. Okay, so if this pixel is completely white, means if so this image is a grayscale image. For a grayscale image, we do have the intensity value variations starts from 0 and it ends at 255. Here the 255 indicates that the pixel or the location or the object is completely white, and 0 indicates that it is a logic 0, where that point is completely black in color. So the same thing you can observe here in this slide. Here the right side pixel is completely black, hence its digital representation is 0, and here this pixel is completely in white in color, so it is completely a logic 1, hence it is represented by a highest grayscale value or a grayscale intensity level, that is 255 here. So that means for each and every box or for each and every pixel, we don't have the same color or we don't have the same kind of texture here. Hence, for each and every box, we possess different shades where we get different intensity values that is being depicted here. This is my digital image. So this is my sampled one and this is my quantized one. That is what you can see here. And of course, this digital image, it is a 2D array of numbers. So what sometimes happens is, to improve the visual quality of image, we need to manipulate these numbers. In fact, quantized intensity values, these all are nothing but. So we need to manipulate these values, and sometimes what happens, some kind of a noise also may attack this image. Because of this noise, some kind of disturbances may also create in the images. So to remove the noise from the image, we also may need to manipulate again these numbers. So this is nothing but the processing for the image. Okay, so the same thing I have highlighted again here. A digital image is a 2D array of numbers. The image is defined over a grid. Yes, of course, because this is a grid. This is it is nothing but a horizontal and vertical lines are intersected, right? So we call it is a grid. So each grid location is called a pixel. The same thing I have highlighted here. Each pixel intensity values is represented by a finite number of bits, because ultimately we may have different kinds of images. A image may be a binary image, a grayscale image, true color or RGB, which is a natural image, or indexed image. For a binary image, binary indicates it may be the pixel may have a value of logic 0 or logic 1. That means each pixel can accommodate only one bit. So it may be a 0 or it may be a 1. So 1 bit per pixel. Coming to grayscale image, as I have explained you, the lowest value of a grayscale image is 0 and the highest value of a grayscale image is 255. That means, can I say, in terms of 2 power of 8 gives me 256. So a grayscale image is having 8 bits per pixel. So the 255 can be represented as 11111111. So 0 is represented as 0000. 0000. So that means each and every pixel is represented here in terms of 8 bits. Okay, that is why each pixel is carrying 8 bits in its location or its capacity. Coming to a true color or an RGB image, so we have here red, green and blue channels. Okay, so this image is associated with 3 channels. So that is RGB, and each and every channel is carrying 8 bit per pixel as its information. So in total, when I accumulate these 3 channels, I will be getting here 24 bits per pixel. Okay. And coming to the indexed image, it is also similar with the grayscale image that carries 8 bits per pixel in its representation. An image, if it is of m cross n, that means I am having here a m number of rows and n number of columns, or like this, because you can see right here, this is nothing but n number of columns and this is m number of rows. Okay. Now, for suppose, if let me assume that if L is the number of grayscale levels. Okay. So according to the grayscale image, it is having 256 levels, which starts from 0 and it ends at 255 for a grayscale image. So can I write L, that is 256, is nothing but 2 power of 8, as each and every pixel is carrying 8 bit of information. So L equal to 2 power of k. Okay, k is nothing but here 8 bits. Now the number of bits required to store any digital image, now I can give a representation that is m cross n cross k here. So k stands for the number of bits each pixel is carrying for a particular type of image. So for let me say that this is of pi cross pi image. So if it is a grayscale image, right? So if it is a grayscale image, means the number of bits required to store this image is 5 cross 5 into 8. So you can find out what it will be the answer. This is about the images. Now we also have to learn what are the relationships between pixels. Right. So we know these pixels are represented in the form of a box. So each and every spatial coordinate is having its own location. Okay, its own. Like if it is x comma y. So if it is an x row, it is x plus 1. It is x minus 1, like that. So x comma y is the center pixel location, and x comma y plus 1 is the above pixel location, and x comma y minus 1 is the below next pixel location. In a similar manner, we do have 2 more pixel locations at here as well as here. So this is the 4 neighborhood. That means this central pixel is connected with 4 pixels in its surroundings. That is why it is a 4 neighborhood. And coming to here, the central pixel x comma y is connected with 8 pixels which are in its surroundings. One pixel is at location x minus 1 comma y plus 1, and next is x comma y plus 1, next is x plus 1 comma y plus 1. In this manner, the central pixel is getting related with each and every pixel in its surrounding. So this is the representation for your 8 neighborhood. So corresponding to the neighborhood, one can define the distances from its central pixel or to any pixel to some other pixel. How it will be? Like if this is my input image, I need to find out some distances or distance measures. If A and B are 2 pixels which are located at some x comma y and u comma v. So this u comma v, it may be x plus 1 or x plus 1 comma y minus 1 or somewhere else. That means u is in terms of x and v is in terms of y. Some. So this is A pixel is located at this location and B pixel is located at this location. Now I need to find out what will be my city block distance. So the city block distance is nothing but it is given by, so d4 of A comma B equal to x minus u plus y minus v. We are here seeing the magnitude. So for example, if this is my input image, the city block distance is given by, so you know that for a 4 neighborhood, the representation will be like this. For an 8 neighborhood, the representation is in this manner. So coming to D4 distance, a comma b, that is x minus u plus y minus v. Okay. That means step by step I am doing here. So from here, if I want to go to this location, that means from here, starting is this location. So I want to go to this location. So I cannot go diagonally here. Why? Because it is a city block distance. I need to go through the adjacent cells, not through the diagonal cells or in pixel location boxes. So from here to here it takes one step, and from here to here it takes me two steps. So in total I am taking two steps to reach from here to here. So this is about the city block distance. This is the figure. And coming to here, this is the case that I have assumed that the distance between one pixel to other pixel location is 1 unit. Okay. Now coming to the chessboard distance, to wherever the location you go, because it is a 8 neighborhood, to wherever the location you go in your 8 neighborhood, it takes me only 1 unit. It gives me a 1 unit as its difference between a pixel to its pixel. So if I would like to go from here to here, so it takes me a 1 unit. So from here to here, it takes me a 1 unit. The same thing is reflected here. So this middle one is nothing but it is my starting location or it is my central pixel. Now what is the concept of the Euclidean distance? So I am having 2 points a comma b which are situated at x comma y and u comma b. Now the Euclidean distance is nothing but it is the square root of x minus u whole square plus y minus v whole square. So for example, let me assume that from here, so from here to here, if I want to go, like in the concept of Euclidean distance I'm talking now. So it assume that this central pixel is at location, let it be, if it is 0 0 0 1 0 2, okay, this is 1 0 1 1. So can I say 0 0 means, can I say it as 1 1, can I say it is 2 2? So it is 1 1 location and it is 0 0 location. So according to the concept of the Euclidean distance, if I need to find out the distance between these 2 points. One pixel is at a this is a is at this location and b is at this location. So that means root of 1, this is 0 0, the coordinates for this pixel is 0 0 and the coordinates for this pixel is 1 comma 1. So finally I am going to obtain as Euclidean distance as root of 1 minus 0 whole square plus 1 minus 0 whole square, that is root of 2. In fact 1.4142 is the value at that I would like to. Finally it is resulting as 1.4142. So the same thing is reflected here. And from here to here, if I would like to go, what I need to substitute just directly the coordinate values for this pixel location. Okay. So it is 1 comma 1 and it is 1 comma 0. So just substitute the values in this equation. Ultimately I am going to lead the 1 as the distance, Euclidean distance. So let me raise you a question here. Find the different distances for 2 pixels which are located at 70, 40 location as well as 30, 330, 228 pixel location.